There are statistics for peak level and for cluster level. First, we have to define what is cluster of significant voxels. Cluster is a group of voxels where the statistical score is higher than the threshold, and those voxels touch each other so that they comprise a group of voxels of certain statistical significance of a certain size, and this size, the number of voxels, the number of significant voxels touching each other, is indicated in this column. This is a large cluster, this is a small one, this is even smaller. What is interesting is that even if the peak is not significant after correction for the volume of observation, there is another score which allows to estimate the significance of the activation, which is the cluster level statistics. Here you can see that there is also one score for uncorrected statistics and the other score for corrected. This one is very useful because it allows to identify the clusters which the size of which is big enough to be extremely unlikely to happen by chance. This means that even if you set a very permissive peak level threshold, but the clusters, the voxels group together and form a large cluster, this cluster, not the peak, not a single voxel, but the cluster in total, will be considered significant, and it can be reported as a certain finding of the study. However, if you speak about cluster level significance, you are not allowed to claim that it was significant at those coordinates, because none of the voxels which have coordinates is significant enough. Okay. Now I propose to follow the instructions from the manual and step by step do what they propose and see if we can achieve similar results. Before we do it, I would like to remind you that it is very nice to project the activation blobs or clusters onto the normalized anatomical image, which is located here. And it is pretty convenient to navigate clicking on the coordinates from the table. So this is the maximum peak of all the responses, and it is possible to identify approximately what is the anatomical structure it is. Yes, it is ventrolateral occipital cortex, but now we can identify more precisely. As expected, it is fusiform gyrus, and you can see other peaks of the same cluster. You can see different clusters. This is on the left, the same brain area. This is something in the prefrontal cortex or premotor cortex, a bit of insula, everything absolutely significant. But at the moment it is simply an average response from all the conditions. And probably next in the manual they will propose something to compare the conditions and to test the impact of the factors. That's why we did factorial design. So this is what we see at the moment. Statistical tables is something we've already discussed. They propose that we can plot the response with confidence interval. It is proposed that we can plot average effect of condition. It will give us 3 bars with confidence interval error bars that correspond to the 3 functions combined in order to adjust the wave shape of the hemodynamic response to what happens in the brain. So we go to the maximum, we click on plot, we select contrast estimates and select contrast average effect of condition. As you can see, all these 3 look quite significant. That means that in total the response, the hemodynamic response in this brain area to those conditions is a bit shorter and earlier and a bit more sharp than the canonical wave shape. This is for canonical HRF function. This is for the time derivative of this function and the dispersion derivative. Let's change the contrast and look at this contrast directly. Obviously it will be also significant in this spot. Yes, as you can see, it is maximum. But what is interesting is to see how the contrast matrix looks. This row quotes any effect of the canonical function. This is for the time derivative, and this is for the dispersion derivative. Let's see other cluster, smaller one, rather this one, from the anterior insula. If the wave shape of the response to the faces, to faces in general, irrespectively to the factors, has the same features as in the occipital cortex. Apparently not. As you can see, neither the time nor the dispersion derivatives demonstrate significant effect, and the only significant activation is observed for the canonical response. That means that the wave shape of the hemodynamic response is different for those areas, and we can actually plot the wave shape of the responses. I go a little bit ahead of what is described in the manual, but it can be interesting for you. So we plot this time event-related response. We select any effect, let's say N1, and plot fitted response with confidence interval. So this is for N1 in the insular area. Now we can click on hold here in the interactive window and plot another response to the same condition from a different area. And probably you can see that this response is a bit sharper and earlier than the other one. It is possible to plot it in a different way with Peri-stimulus histograms. So this is the fitted response, and those are the average from tiny beans of about 2 seconds, about one scan. Just after the stimulus, the next, the third scan after the stimulus, and so on. So this is from the occipital cortex, and this cluster is, I forgot to click on hold. This is from insula. Yes. Here it is also quite obvious. First, the response is sharper, and second, the undershoot is much more pronounced. So the expectation is about difference in the wave shape are achieved through the F contrast driven combination of different derivatives turn to be true. Now let's examine the F contrasts as recommended by the manual. Click on Results and select the SPM12 file. Here we need F contrast number 3, the main effect of repetition. In this particular case, we apply masking to a certain extent. This means that we are going to examine this contrast only within significant positive effects of condition 1. This means that we are interested in the effect of repetition, whatever is the effect, either the increase or decrease of the response at the second presentation, but only in those brain areas which respond to the average of 4 different conditions. So in general, in those areas, the response is already observed, and we further identify if there is an effect of time. The uncorrected mask p-value will be set to 0.001, and the mask is inclusive. That means that only those areas which are already activated by the presentation of faces in general will be analyzed for the modulation by second presentation. And they advise to accept uncorrected statistics with threshold 0.001 and no extent threshold. As you can see, there are very little such areas which demonstrate the effect of second presentation, and this is obviously non-significant. Neither the peak nor the cluster level. But this still can be relevant if at the second level, at the group level, such small effects will be superimposed, or in other words, located in the same brain area across subjects. So we go to the global maximum as they advised, or it can be done in this way, absolutely equivalent. And now we are going to build event-related responses for F1 and F2, like we already did. By the way, let's see if this is the fusiform gyre. Yes, it is. On the right, and we plot the event-related responses of F1, which is famous phase's first presentation. Fitted responses and Peri-stimulus histogram. Hold, and we plot again the same, but the second presentation. And again, Peri-stimulus histogram. It is quite obvious that the amplitude of F1 response in this particular spot of the brain is smaller at the second presentation. You can further explore further F contrasts, which are a powerful tool once you understand them. What I would like to do is to create an F contrast which will allow me to examine the differences in the average effect of each condition separately. So I call it F each condition, and you can either create a matrix where you indicate the conditions to be compared, something like this. Let's see if it works. Not really. Let's adjust it a little bit. We need this white bar to stand above each main response. So this one has to be a bit later, like this. This is correct and we can use it. The other way is to indicate which columns must be excluded. And here we can type 2 to 3, 5 to 6, 7 to 8, and 7 to 8, and let's try. No, not really. So it's going to be from 8 to 9, and from 9 to from 11 to end. Just like end, we can type it as 11. So this gives exactly the same. We submit it and it gives us that the contrast is valid. So we type OK and we can click done to see what is the outcome. We keep in mind that the coordinates of the peak where the repetition effect is the most significant are 45, minus 61 and minus 10. Let us enter the coordinates and see if there is something significant with this contrast. Most likely there is. Minus 61 and minus 10. Here it is. Not the most activated area, but quite activated. And now we can plot the very same contrast outcome, F each condition. Here you see 4 bars, each bar for each row of the F contrast. And here indeed you can see that to a greater degree for the famous faces and less so for the non-famous. If you remember, the order is exactly like this: non-famous first presentation, non-famous second presentation, famous first presentation, and famous second presentation. So both of those conditions demonstrate the effect of the factor repetition. Now in the shape of decreased overall amplitude of the canonic hemodynamic response. Here we have a decrease in the response to non-famous, and here we have a greater apparently decrease of the response to famous. But the significance of this effect is quite low because of a lot of noise. We can see, as it is recommended in the manual, the movement related effects. And in this case we will set the new contrast manually again, and it will be another F contrast. We define new contrast again with columns 2 for reduced design. It is suggested that we enter 1 to 12 and 19 to be excluded from the F matrix. Those are the experimental conditions, and the last one is the average. And the rest, 6 regressors, correspond to the 6 reorientation parameters. So in this case we are going to see the cerebral responses related to motion. We call this contrast F movement related activity. And click OK and click Done. No masking is needed. And let's project it on the previous sections. There are a lot of activity in the occipital cortex, and now it is masked. Sorry for this. We will restart the review of this result. So now we apply no masking, and we can keep it adjusted for multiple comparisons, but still you'll see that it is very significant, and there is a lot of responses to motion everywhere, or better to say the artifacts. You see, this is a typical pattern of the artifact because it is located at the border in the white matter next to the ventriculi. It is quite possible that there is also some physiological activity, but it is extremely difficult to discriminate physiological activity related to the motion inside the scanner and the artifact which is created by the motion and displacement of the image. You might say that the motion shouldn't produce a lot of problems, since we corrected for the displacements during the realignment step. It is partially true, but imagine that the displacement have happened just in the middle of the scan. This will change not only the orientation of the image, but also the shape of the image. Some slices can be acquired 2 times, and the brain will be stretched in the vertical direction. And this, unfortunately, cannot be corrected. So we just model all the displacement parameters, and all this activity is not taken into account, or as it is called, controlled for, when we examine the other conditions. Now let's move to parametric responses. Here we need to look at our presentation again. This is a design matrix that will be achieved from the parametric responses. This is the same, the motion parameters, but this part looks different. And why does it happen like this? You will see when we run again model specification. So in the batch editor, we open the file that has been created for model specification. I believe this is the correct file. Here we are going to change a number of parameters. Let's look at the menu. So first, we don't forget to load sorts. Other way to load it is to just drag and drop it to the command window. So now it is here, SOT, and item lag. This one will be necessary for us because the onsets of the conditions are exactly the same as before. The scans, the number of scans, we remove the derivatives to simplify the design matrix. The factorial design is the same, but for the second presentation, which is N1 and F2 for non-famous and famous, we will add parametric modulators. We click new parameter, we call it lag, and we enter the values, which is item lag 2, and the polynomial expansion of the second order. And about the same for F2, also parametric modulations, also lag. This time it will be item lag 4. Okay, and polynomial expansion of the second order. I believe the rest of parameters stay the same. Very important, don't forget to change the directory. For statistical analysis, we create a new directory, which will be Parametric, and we change it here. So we unselect Categorical and select Parametric. Done. Now we save it to another file. Parametric specification, and we run it. So, how to understand those additional columns which go after each second presentation? What is the lag? The lag is the interval between the first presentation and the second presentation. So we need to know if there is any effect of the time between the first and the second presentation on the response when the image is presented second time. This is, in other words, modeling Parametric design is modeling of a feature of a condition as continuous variable. For example, the interval between first and the second occurrence of the presentation of the same phase. In this cartoon example, you can easily imagine a parametric modulator with the weight of one unit. For example, for lemon it is 100 grams, for watermelon it is 300 grams, and so on. And in this case, in addition to 4 different categories, we can also estimate the impact of the weight of the unit on the final response, whatever is the readout. Let's see how do they propose to do this in the manual. Of course, we are going to estimate the model. This is quite trivial, but don't forget to save everything. And we run it. Now the last step for this part of our class at the moment is to plot the parametric responses. I believe it is finished. Yes, you see that it is done. And we go to results and we define new contrast. Specifically for the parametric modulators of the famous phases. It is F contrast you call it famous leg, and you enter here 1 to 6 and 9 to 15. Those will not be included, and only 2, the 7 and the 8, will be included in the design matrix. So everything is good. You see it is highlighted in green. We click OK, then we select it and press done. We apply masking as the positive effect of condition 1. In general activation due to presentation of the faces. Uncorrected 0.05, we leave it like this. The mask is of course inclusive, and no correction will be applied because otherwise we will not see the effect. Cluster of a reasonable size, still not significant, and non-significant anyway at the peak level, but let's see this trend. First of all, where it is. Here is the biggest cluster, and it appears to be something like somatosensory cortex. Let's try to identify it using the automatic anatomical labeling. White matter. I don't believe it is white matter, it's more like post-central gyrus, which is somatosensory cortex. Who knows why it happens? Personally, I have no idea why this part of the brain is, why the response to the famous phases, this part of the brain is modified by the interval between the first and the second presentation. But let's see what is the shape of the modulation. We press plot and we select parametric responses and we pick F2, and this is exactly what is expected. It is a non-linear modulation. The response with the increase of the lag to 40 seconds, I believe, becomes greater at 5 seconds post onset, and then it becomes smaller. I think this part of the presentation can be finished. I wish you best luck in your studies of SPM and playing with data. It's very exciting. And the next video, if it will ever be issued, will be about the group level statistics. Thanks to everyone for listening.